Hello students, and welcome to this lesson on proportionality and similar figures. Our objective today is that we will examine what happens to area when the dimensions of a figure change using journal notes and an activity. Alright, so first off we need to talk about something called a scale factor. And a scale factor is a number which you're going to change your measurements by. And those changes are going to be multiplication. So a scale factor is a number which is multiplied by some measurement so that it changes. And we can have a scale factor that will influence one side of a figure, all sides of the figure. Most of the time it's going to be all sides of a figure. So its effect on area and perimeter depends on how we use it, right? So for instance, this square, has a side of 6 and another side of 6. Then we take this and we multiply it by a scale factor 2. We could also write this as a ratio. We're going from 1 to 2. And so over here, we are doubling all of our measurements. So we see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 to a side. And so we see that these new measurements are 12. And we will see that there's an influence on the perimeter and on the area. So the perimeter... The original perimeter was going to be 6 plus 6 plus 6 plus 6, and that went from 24 to my new perimeter is going to be 12 plus 12 plus 12 plus 12, which is 48, so that's going to be 48. Then we have our area. Alright, so our original area is 6 times 6, or 36. And my new area is going to be 12 times 12, which is 144. So let's see what my scale factor 2 did to my perimeter and to my area. So this ratio, this first ratio, will become 1 to 2, right? Because they're both divisible by 24. So we see that my perimeter ratio is going to be 1 to 2, but my area ratio, 36 and 144, well, 144 is actually divisible by 36, and I see that I have a 1 to 4 ratio. So, while my perimeter became twice as large, my area became 4 times as large. And that makes sense because we could divide this into 4 pieces, and we'd be able to fit 4 of these in here. So that's an interesting effect. So our scale factor looks like it was actually doubled when I went to do my area. So this first factor would be A to B, and the second factor would be A to B, where both of them will be squared. Alright, so let's look at some examples. Alright, so for this first triangle, alright, so we have a 1 to 2 ratio here because we look at the heights. That's really what we're going to look at here as far as making sure that we know what we're doing. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And this one over here was a 7 height. So we'll see that they will be proportional. And so let's just think about what the ratios of their areas will be. So the perimeter ratio will be 1 to 2. So that means that my new perimeter of my bigger figure, if this is 8, 8, and 10, then my new perimeter should be double that. So 8 plus 8 is 16, plus 10 is 26. So my new perimeter of my new figure is going to be twice that, and that will be 52. Then area, we know that, well, it's a scale factor 2, so it becomes a 1 to 4 factor. And if we take 10, let me just do something real quick. So according to the numbers, this height will be the square root of 39. So to find that, to find my area, we would say the square root of 39 times 10 times 1/2, so that's going to be 5 square roots of 39. What's great about this is that now to find this area of this triangle, all we have to do is follow our ratio. So we say 5 times 4, right, because that's our scale factor that we use, and we get 20 square roots of 39. So we see how this makes it a little bit easier to find these larger figures. So these similar figures will share these ratios, and that makes it a lot easier for us to actually find the scale factor. All right, so go ahead and answer these questions, and then go ahead and ask me. I'll give you a stamp. Your in-class assignment today is to find the ratio of the figures and to do your proportional dimension change.